Hello and welcome to Study Time, your Mathematics Success Center, Session 1, Algebra Basics. In this session, we will look at slope, slope-intercept form, and the flow meter. If y is a linear function of x, then the coefficient of x is the function slope. When represented in slope-intercept form, which is y equals mx plus b, m is the coefficient of x, and b is the y-intercept, where the graph crosses the x-axis. Slope-intercept form. The y-axis formula is y equals mx plus b, where m is the slope, and b is the y-intercept. The x-axis formula is slightly different. X equals y over m minus b over m, where m does not equal 0 because you cannot divide something by 0. M is the slope, and b over m is the x-intercept. Here we have an example of identifying where the slope equals 1/3. You'll see that for 1/3, which is what x is, you have to move to the right 3 and up 1. Here you see a run of 3 units, followed by a rise of 9. 9 over 3, which equals 3, indicating that the slope is 3. The flow meter. Fluid flow is defined as the amount of fluid that travels past a given location in a certain amount of time. A flow meter is a tool used to measure fluid flow. This is something that uses the slope-intercept form quite often. A flow meter is a small electronic device that is attached to the bottom of a pipe by 2 curved sheets of metal. It records the water level at a preset time. These flow meters can remain in a pipe for years on end. They are attached by wires to a metal tube, where there are more wires that can be attached to a laptop. The laptop then receives the messages, and engineers interpret the levels and make decisions. These decisions could lead to evacuations, or preventative measures like creating dams. So what does a flow meter do? Well, this device is mostly used to keep a close track on the water level. When the water level exceeds a certain mark, usually a little bit below the halfway mark, the pipe must be replaced with a larger one. Pipes are constantly replaced when they are in areas of drastic water level changes. Here's an example of a pipe and then identifying the halfway level. You'll see the flow meter at the bottom, demonstrating that it's currently below the halfway mark, and therefore this meter is accurate. You can see there are wires leading to the surface, so that way it can definitely identify when the water increases.